All right, Josh, why don't you go ahead and get started?
Okay, well, good morning, everyone, and I appreciate you guys coming. And this is obviously our, I think, third Latte and Learn that we've had, and these have been really well received. And so excited to get going on our green buildings topics. And so we've got a fun one this morning. My name's Josh White. I'm the CAR Professional Development Master Group Chair this year, and I just wanted to say that we appreciate our partnership with the Blue Ridge Home Builders Association, and we're excited to kick off the Green Building Series today as well. So the series was produced to help you understand the various green components in relation to planning, design, construction, maintenance, renovation, and demolition. And today's session, we're going to be covering building systems. And we are very fortunate to have with us today Jimmy North of Airflow Systems and Alicia Farmer of Sunday Solar. Before we get started, I want to remind you that participants of today's event have access to the incentive that we're doing through the NAR Green Designation 2-day course. So if you attend 4 out of the 5 Latte and Learn green building sessions, you're going to get a $100 discount on the designation course. So that's a 50% savings for that. Also want to say thank you to our green building sponsors. We have Birch Studio, Fulton Mortgage Company, Guaranteed Rate, and UVA Community Credit Union and member options. Thank you guys very much, and thank you for helping make the incentive possible for us as well. So since you're not able to visit these sponsors in person, please review the handouts to learn more about the companies, and if you have any questions about them, let us know. So we're going to get started with today's session. And we're going to start with Mr. Jimmy North, who's the president of Airflow Systems Incorporated, and he's going to present how to size and design HVAC systems in today's green homes. And he's going to provide an overview for us of the types of systems available to clients, as well as cost for purchase and maintenance.
Well, thank you, Josh. Appreciate you having me. So yes, my name is Jimmy North. I own Airflow Systems Incorporated with my wife, Mary. We started 33 years ago in business. And by the way, I was one of the first 6 earthcraft inspectors in the state of Virginia back in 2005. Trying to bring green building. This is not something that just happened yesterday. This has been going on for quite some time. And fortunately or unfortunately, the HVAC part of things is the hardest part to get right when it comes to homes. As houses get tighter and tighter, we actually have to mechanically ventilate them. For instance, in Grandma and Granddad's house, they leaked so much that it was not a problem. Around windows and doors and so on and so forth. And now in the 21st century, we understand that windows and doors leak air, and now we actually seal off areas that where the air is actually coming from. To kind of explain it to you, so people just don't understand how high performance houses actually work. The walls and stuff of the house are a lot tighter and they don't leak air. So in today's world, we actually have to mechanically ventilate them. We actually have to bring in outside air to the HVAC system. So when you run an exhaust fan, bathroom exhaust fan, a kitchen fan, or your dryer in your house, that air has to come from outside the house, in the house, and back outside of the house again. So you guys get people that are able to be able to handle the mortgage of a house. A HERS rating is kind of like the miles per gallon as far as a house is concerned. I would venture to say that not in my lifetime, but I think that you're probably going to see, a HERS rating in the MLS. Again, it probably won't be in my lifetime, but it's like when you go to buy a car, you buy the car that you like, and then of course the next question is how many gallons per mile does this car get? And in today's world, when we do blower door testing the structure of the house and how tight it is, and the duct system, how tight it is, then you have a benchmark, so people can afford the mortgage of the house. but they can't afford to live in the house because their utilities are too expensive. So now in today's world, we know enough about building science that we actually put controlled ventilation in homes. And Energy Star, now you have to actually mechanically ventilate the house. You actually have to bring in outside air to the HVAC system. And that's 7.5 CFMs, cubic feet per minute of air, 2 people in the master and 1 in each bedroom. So when we do habitat houses, we actually have to present outside air into the house, so the house doesn't go into a negative pressure. Another thing, wood burning fireplaces don't work in high performance houses without opening a window or opening a door. That's the only way that they're going to work. They just don't work because the house doesn't leak air. So therefore, again, the air's got to come from outside the house in the house to go back outside of the house. And then of course, you have to be concerned about the things that's in the house because of it being a new construction house. The things that are outgassing, for instance, the carpets and the formaldehyde, you have wood floors that we put urethane in, and you can smell all that stuff. So by bringing it outside, because we don't open our windows anymore. I don't know about you guys, but when I was growing up as a kid, we didn't have central air conditioning in our house. So we actually opened the windows. And we don't do that anymore. It just, we just keep everything closed up. So in today's world, we've got 2 options. One is outside air ventilation controller, that you actually run a duct to the outside of the house and you actually introduce it to the return side of the HVAC system in order to be able to introduce outside air into the house, and you cycle the fan every so often to introduce outside air into the house. And of course, that's also a pathway. So when bath fans are running or kitchen exhaust or dryer vents, that is the pathway for air to be able to come into the house to feed that particular fan or dryer to be able to go back outside again. And of course, it's conditioned, it's conditioned air. The other way of doing it is by using an energy recovery ventilation system. We happen to be in climate zone 4 in the United States, which is the hardest HVAC design in America, because we get a little bit of everything here. And so, we can't cover everything. So we use energy recovery ventilation systems south of the Mason-Dixon line, and they use heat recovery ventilation systems north of the Mason-Dixon line. And what an energy recovery ventilation system does for you is that actually allows you to have a neutral pressure in your house. Outside air ventilation controller actually allows you to have a positive pressure in your house. An energy recovery ventilation system actually you have a neutral pressure as far as your house. It is adding expense to your HVAC system because you're having to buy something to be able to bring that outside air into your house. And what it is it's a machine that actually tempers the outside air coming in and picking up moisture and driving it back outside in the summertime. And again, energy recovery ventilation is south of Mason-Dixon line. Heat recovery ventilation is north of the Mason-Dixon line. And so what's happening, so for instance, somebody wants to get a price on HVAC system, they'll bring me their house plans. We run a heat gain, heat loss load on the house, which is called a manual J. And what's happening to us is our houses are getting larger physically, but the loads are getting smaller and smaller. So it's not a large piece of equipment. So everybody in their mind would speculate, well, if it's a smaller piece of equipment, it's going to cost me less money. No, not necessarily, because you still have this mega house that you have to heat and cool. So you have all the ductwork and everything that you have to do in regards to that. So not necessarily is it making it any less expensive, but it does does create some challenges for us. But going back to the sizing and the design, so the homeowner will tell us, the geographic direction that the front door is facing. Something that's very, very important in our industry is the solar heat gain coefficient of the windows and the U factors of the window. The U factors of the windows are the insulating value of those windows. The solar heat gain coefficient is the, in the wintertime, you know, with the sun being lower in the sky, it actually allows the radiant heat to actually help heat up the house in the wintertime. But then when it's higher in the summertime, it actually reflects that. And so as long as you're using windows that are 0.35 or less, those are good performing windows. That's a big deal when it comes to loads as far as houses and stuff like that is concerned. And then of course, it's all about air infiltration, you know, how, you know, the house, you know, where is that when we have the dryer vent running and the kitchen exhaust running, you know, I've had people that, you know, had fireplaces in their house, and, you know, of course they'll, you know, and everybody in their world just thinks everything is, if it's bigger, it's better, you know, so they'll use the Benford 12,000 CFM kitchen exhaust fan. You know, I mean, I've actually had people set their sofas on fire because they turned on their kitchen exhaust fan and they had a fire in the fireplace in the actual chimney. The air actually goes to its least amount of resistance, pulls back down into the chimney, and actually caught their sofa on fire. You know, so now that we have, we know more about building science in today's world and how things function, and, you know, we have to control the outside air that's actually coming into the into people's homes. I try to explain it to people, you know, if you took a 1 gallon milk jug and you sucked on the end of it, you know, what happens to the sides of the milk jug? They collapse. So if you think of an exhaust fan in your house or a dryer vent or your kitchen exhaust hood, you know, that outside air has to come outside in the house. Previously in years past, it was coming around your windows and doors. Now it's not coming around your windows and doors. And that would be your feet of air, which is costing you a lot of money because you're having to heat and air condition that air. Now we can control that and actually introduce that air into the HVAC system, or you can actually install an energy recovery ventilation system to be able to control that air that can feed those items that's sucking air out of your house. I try to explain it to people like this. In 2025, when the code gets adopted, you know, we're building houses to the point of the tightness of an igloo cooler. You know, and what we've been doing all these years is we've been putting what I call the ice cream maker, the air conditioning system, on top of the igloo cooler, and we've been piping it down into the homes. You know, so we take the ice cream maker, we put it in a 150-degree attic. Well, we know enough about building science now and about energy loss in homes that in 2025, all of the equipment and all of the ductwork have to be in the envelope of the house. So what's that mean? That means you're actually opening the top of that igloo cooler and you're putting your air conditioning system down inside of the igloo cooler, and now you're closing the top on it. So it's less capacity of equipment that's necessary to heat and cool that house. Plus, you don't have to worry about any duct loss, because any loss of your ductwork is actually still going towards the energy of the house. So if you have a system that's in an attic, that's a vented attic or a vented crawl space, and let's just say that your ductwork leaks 20%. 20% of what you're paying for every time your system runs is not going towards the heating and air conditioning of your house. It's just going to the outside of your house. So what you're going to see is you're going to see the more the back of roof decks in houses that are insulated, and you'll go in your attic and you won't have any insulation on the back of the sheetrock at all. We're going to have to bring all of that stuff into the envelope of the house because it's about the energy that's lost through duct leakage. Dominion Virginia Power did a study back in 1990, and the minimum duct leakage that they found in the Charlottesville area was 40%. So 40% of most of what people were paying for was not going towards the heating and air conditioning of the house. It was just being wasted. So when Casey was talking last week about Earthcraft House and, you know, how we can in homes consume a majority of the electricity in America, you know, we are running out of electricity in America. You know, and when we've got to start checking off all the boxes, we got to check off solar, we got to check off geothermal, we got to check off wind, we got to check all that stuff off. Because 50 to 100 years from now, you know, if we keep building houses the way that we are, you know, we're not going to be able to sustain what we have going on. And a couple important facts that's pretty sad is we lose 85% of our energy transmitting it to us. So we're only getting 15% of what's being made. And that's just due to the fact that our infrastructure is so old and that it has not been updated. Imagine if we could turn that around, you know, and it was the other way around, that we were only losing 15% getting to us, but we had 85%. You know, that would be pretty amazing, you know, that if we could do that, but we're not. It's just not happening that way. So, you know, like I said, you know, solar, wind, geothermal, all of these things, you know, we're going to have to do that stuff going further in the future.
Thank you, Jimmy. Does anybody have any questions for Jimmy?
I do. This is David Robinson from Birch Studio. Appreciate the information on the upcoming 2025 code. Jimmy, is that going to be national or is that state by state, where the air handler and ducts need to be within the envelope?
Well, like she said earlier, you know, we're still working off the 2015 code. You know, we're trying to get up to the 2018 code. You know, so it's actually going to be supposed to be 2020 code in 2025. So, you know, it's just one of those things that, David, I mean, one of those things that, you know, if we already know that now, you know, why aren't we trying to achieve that now that we know it? You understand? You know, so it just makes sense to me that, you know, and what a lot of people don't realize is, you know, 70% of your loss is in the roof of your house. You know, hot air rises and cold air falls. So any of you guys have whole house fans, you know, growing up as a kid, you know, that was people's air conditioning because they didn't have central air conditioning. You know, they turn on the fan and crack the windows. That's a huge energy loser in your house. You know, I mean, that's like having a window that's open in your house at the top of the stairs if it's 2 foot by 2 foot. It's like having a window open year round. You know, that's your snow melting machine in the wintertime when we have 6 inches of snow on the roof. You know, recessed light fixtures. You know, I know that we use them all the time. You know, and every time that you cut a hole in that sheetrock, the skin of the house, you're just giving that heat a path of least resistance to leave your house. So that's where a lot of energy consumption, you know, that we can save money on just by, you know, making the envelope of the house. So what you're going to see is you're going to see what's called conditioned crawl spaces. You're not going to see vented crawl spaces anymore because those have a lot of health issues to you about sucking all that air that's underneath of your house that's got dirt and all that stuff, introducing that stuff into your house, and then as well as you know, sealing up the back of the roof deck of the houses. So don't know exactly, David, when that's going to happen, but that's coming down the pike.
Anybody else?
Yeah, Jimmy, great presentation, by the way. I've always had a particular interest in geothermal systems, and I was curious to know what their prevalence is in Zone 4, which, as you stated, covers our area, if that's a viable option for here, or if that is more applicable to colder areas.
Not at all. Not at all. I've had geothermal in my house for 25 years. I knew about tight homes 25 years ago, so I live in that house. In my house, and so the nice thing about geothermal is it lasts twice as long as a conventional system. It's warmer heat. It can also produce 50 to 75% of your hot water needs in your electric hot water heater as a byproduct of the geothermal. It's actually your biggest energy savings things that you could do when you go build a house. Certainly you have to have some land in order to be able to put the loop and stuff like that in time. But it's the most energy efficient thing that you can do. I changed mine out when it was 23 years old. It was still running fine. The tax credit was going away and I was going to get my 30% tax credit. So I went ahead and changed my unit, even though it was running, just so I could take advantage of the tax credit. And the tax credit's still good for this year of 26%. And then 2022, it actually goes down to 23%. And then who knows where it goes after that, with the next administration.
Do you find them viable for retrofit situations?
Oh, absolutely. I mean, it's kind of amazing. So, I have a extremely tight house. I got 2,600 square feet. My average operating cost a month is about 110 bucks. And it has been for, it was less than that until Dominion went up, but no, I'm 110 bucks a month. So it's very consistent as far as its temperature is concerned. And we're just using the water as a medium of it being able to transfer energy. The earth stays 55 degrees year round. And so that water temperature gets as hot as it's going to get in the summertime. And then in the wintertime, it gets as cold as it's going to get. So you'll send it out to the earth, it runs through the pipe, it comes back in, you picked up 10 degrees as far as the earth is concerned. And then when you switch over from season to season, you're really ultra efficient. So you'll spend $5 and you'll get, you'll spend $1 and get $5 worth of heat or air conditioning out. It's the most energy efficient thing that you can do. And I've been doing geothermal. I was the first one in Charlottesville to start doing geothermal. And I've been doing geothermal in Charlottesville for about 32 years.
Thank you.
Yeah, thank you. All
I
right.
find it interesting when we talk to people about retrofitting houses, the payback is always a big concern because it feels like a large chunk of money up front. There's some education that goes into it because you can tell somebody a whole house fan is bad and they will tell you how wonderful it is because then they can turn it on and reduce their air conditioning time. But we can handle the education part. How do we explain the payback? How long does that take? Certainly in new home building, it's already there, so that's great. But a lot of retrofit still needs to be done.
Well, that's Quentin kind of easy to be able to do in regards to, what you've been paying and what your source of energy is and what you're using for the house. So typical payback in this area is about 4 to 6 years. That's if you were able to do a horizontal loop. If you're drilling and having to go vertical, you're more like an 8-year payback. Having done it as long as I have, that's a, and of course, the loop is a polyethylene product. So according to environmentalists, that's a forever product. You can't burn it. We can't send it to the landfill. We can't do anything with that. And the earth is, like I said, it's just a wonderful insulator and it's a great thing to use. And of course, geothermal has so many different benefits. You have no outdoor unit, so you're not sitting out on your back deck during the summertime and having a big party and sitting there listening to your air conditioner run on the outside of the house. So there's a tremendous amount of benefit to it. So the least thing that you could do was, like I said, you spend a dollar for electricity, but it gives you $5 worth of heat or $5 worth of air conditioning. We actually have one unit now that's actually what's called a Series 7, and that's spending $1 and getting 7 units of heat or air conditioning out of it. So, it doesn't take long for it to pay for itself. Plus, it lasts twice as long. So you're talking about a 24-year life expectancy versus a 12.5 to a 15-year life expectancy. What's that second system going to cost you when you go to replace it in 12.5 years? So that's all part of that calculation too.
All right. Thank you. Thank you, Jimmy. Appreciate it. All right. We're going to go ahead and move forward. Next, we have Alicia Farmer of Sunday Solar, and she's going to present Green Builder and Renewable Energy. and she's going to cover enhancements in renewable energy, such as technology, government incentives, solar panels, batteries, and inverters. And she will also discuss long and short-term costs and benefits as well. So, Alicia.
Good morning. Thank you so much, Josh. I really appreciate it. I'm going to go ahead and try to share my screen here. I'm Alicia Farmer. I work for Sunday Solar. Sunday Solar has been installing PV solar installations for about 10 years now. Sorry, let me get this presentation going. There we go. Okay. Can everyone see the presentation? Are we good? Someone give me a thumbs up. Cool. Awesome. All right. So as Josh mentioned, we're going to go over the advances in the renewable energy industry, and identify the short and long-term cost benefits. When Jenny from the Blue Ridge Home Builders Association reached out to me last month to come on and talk to all the realtors, she had sent me quite a long list of questions that all you realtors had for the renewable energy industry and about solar. So I really want to fine tune and address those questions, and hopefully we'll have time to review some questions after the presentation. So one of the main things that has happened over the past year or so has been the extension of the 26% federal tax credit incentive. As of the last week of December 2020, if you had your solar system installed in 2020, you were still going to receive the 26% federal tax credit incentive. But if you had your system installed in 2021 or 2022, that tax credit was actually going to decrease, just like the geothermal tax credit is decreasing next year. And it wasn't until actually the last week of last year where the new administration actually extended that 26% federal tax credit incentive. So homeowners are able to take advantage of that 26% federal tax credit incentive off their entire solar project if they have their system installed in 2021 or 2022. And then we're not really sure if it's going to get extended again, or, no one really knows what's going to happen, but that is here for the next 2 years. Another thing that happened last year that I'm sure you all know about is a piece of legislation that was passed by Governor Ralph Northrup, the Virginia Clean Economy Act. And the act is really designed to encourage clean energy job creation and reduce the state's carbon emissions. So the overall goal is to have zero carbon emissions by 2045. And just completely move to clean energy. So those two things were a huge step in the right direction towards the renewable industry. Just in knowing that the administration is behind us and really believe in having a cleaner way to make energy. We really need more energy, and clean energy is what we have to do to sustain the building that we have. So I've only been in the renewable industry for about a little over 2 years, and I've been working for Sunday Solar since August, and the renewable industry is changing constantly, and I haven't done much research about the history of solar panels, but I thought that this was really interesting. Solar panels were only invented in the 1950s. And when they were invented, they only had about 5% efficiency. So the panels, they were only producing about 5% of the sun's energy. So over the past 70 years, the real improvements in technology have really been improvements and efficiency. If you guys remember the old what the old solar panels used to look like, with the big blue panels with the silver frames that were just huge and heavy and really inefficient. Like I said, only like 5%. And now you're going to see panels more like these in these photos, all black on black, at about 15 to 20% efficiency, and much lighter and easier to use. We really are still just using the same basic silicone PV solar cells that we did 70 years ago, and that technology really hasn't changed. So the look is different. They're much sleeker, much prettier, much more efficient than they have been in the past, but it's the same technology that we have been using. If you look at this chart here, you can see how the efficiency has gone up, but we really still are only seeing about a 15 to 20% efficiency in these panels. Any sort of panel that you're going to get in the United States right now is only going to be at that 15 to 20% efficiency. So let's go over the cost benefits, what you all really want to know. So the cost benefits of solar, if you add solar onto your home, it's going to increase the value of your home about 4%. That's one of the huge cost benefits of going solar. The other cost benefit of going solar is little to no monthly utility bill. You don't have to worry about that always rising utility bill to power your home. So I wanted to do something a little bit differently for this next section, and I wanted to really illustrate how these cost benefits are cost effective for in relation to a real home. So this is a real home in the Charlottesville area that came to us and wanted to look at what going solar would look like for their home. 5 bedrooms, 5 baths, 2,800 square feet. It is not for sale. It's off the market, but the Zillow off market estimate is almost 2 million. And the increased value by adding solar would be about $47,000, making the home's value a little bit over 1.2 million, which is, almost $50,000 more dollars added onto the value of the house. So it's pretty cool. So this homeowner's, this is this homeowner's Dominion energy bill. This is their July bill of last year. And actually the month that they used the most energy out of the whole year, probably because it's the hottest month of the year, and their home isn't super energy efficient, and they are losing quite a bit of energy just to power their home once you throw the AC in there. So this person is paying about $146 to power their home in the month of July. And they used 1,282 kilowatt hours of energy. So their yearly cost last year in 2020 to power their home, to rent their power from Dominion, was $1,232. And they used about 9,000, almost a little under 10,000 kilowatt hours of energy last year. So they paid about $1,200 for about 10,000 kilowatt hours of energy. So the other thing that people really don't talk about with the utility companies is you are renting your energy. You're borrowing it from Dominion. You're paying Dominion to use that energy, and historically speaking, the utility companies do increase their rates about 4% per year. So just for fun, I wanted to go ahead and do the math and see how much this customer is going to be paying over the next 5 to 15 years to Dominion if they decide that they want to keep Dominion as their power provider. So over the next 5 years, including the 4% rate increase, that's assuming that that happens, which historically speaking, it does. This homeowner is going to give Dominion $6,541 to power their home, to rent their power. And their 10-year cost to Dominion is almost $13,000. And then their 15-year cost to Dominion, what they're going to pay to Dominion over the next 15 years is over $20,000. So that's quite a hefty bill, and you're not seeing any return on that investment, that over $20,000 investment to power your home. There is no investment. It's a rental fee. It's interesting because people buy their home, but then they rent their electricity. And if you think about it with that mindset, that you really are just renting it at this increased rate, it makes a lot more sense with the cost. So let's go ahead and go to the next slide. Okay, so this is this homeowner's proposal with Sunday Solar. They have a perfectly southern facing roof with no shading issues, no obstructions on the roof. And they really only need about a 7.8 kilowatt system, which is only 24 panels to offset their Dominion bill by over 100% every year. So that means that these 24 panels, the 7.8 kilowatt size system is going to produce more energy than their home needs. It's going to produce a little over 10,000 kilowatt hours, which is a little bit more than they need. And honestly, they have plenty of roof space where if they did use more power, they could add more power, and there's plenty of roof space to add a larger system if they needed it, but they just don't. So this total project cost is $20,280. Now that is before the 26% federal tax credit incentive. And the project cost after incentive is just under $14,000. So if we go back to, and I'm not sure that I can go back to the slide, but they're going to hit that mark that paying Dominion, what did we say, a little under $13,000 by year 10. So going solar is the safest, most guaranteed investment that a homeowner can make. In this day and age, it's really unrealistic to think that we're not going to be using that energy. If anything, we're going to be using more energy. The more things that we plug in, the more lights that we have, the more everything, we need more energy. So this is something that is an absolute guaranteed investment, because you're going to be paying for your power either way. You can invest it in your home and into your home value, or you can pay and rent it from Dominion. So a lot of people get stuck on the payback period. What I'm getting to is a lot of people get stuck on the payback period and how long it is. And that's why the payback period with solar just doesn't matter, because it is a long-term guaranteed investment into your home. You are going to be paying for that power either way. So you can take control and be in charge of that investment, or you can rent it from Dominion. Okay. So Benjamin Franklin said, in this world, there is nothing certain but death and taxes. And I would say that in this day and age, there's definitely a third thing, and there's nothing certain in this world but death, taxes, and utilities. And then lastly, I just want to go over the environmental benefits of just this specific homeowner's very small 24 panel, 7.8 kilowatt size system. The lifetime of the system is going to save close to 160,000 pounds of dirty coal, and it's equivalent to planting close to 4,000 new trees per year, which doesn't seem like a lot, but it really is a lot in the grand scheme of things if we can all do our little part in making the environment a little better place for us all. Then here's just a little bit about us, which we've been installing for over 10 years. And we do both commercial and residential. Our office is on Pantops off River Road, and we have a very, very small, experienced team. We do everything in-house, and are really excited to be a part of this Latte and Learn this morning. So thank you all so much for having me. I really want to be a resource for all of the realtors out here with the renewable industry changing so much with the Virginia SREC market opening up, which should be opening up in Q3 of this year. They're still really hammering down the details. There's just so many things changing in this industry that are really, really great things for homeowners in Virginia, and lots of incentives. So I am here for you realtors. Any questions, or if you have customers who have questions, we're here to help. So thank you all so much. Now I just have to figure out how to get out of this.
There you go.
There we go.
Thank you, Alicia. Yeah. I know we had a couple of questions in the chat. How long does the solar system last? That was one good question.
So the solar panels on the solar system are warranted for 25 years. So that's kind of like the basic, long-term, your system is guaranteed to last 25 years. Now we see systems still producing at over 75% efficiency after 35 years. It's only like 0.05 depreciation on the panels. So at year 25, your system still should be producing over 85% of its capacity. But the general lifetime of the system is about 25 years.
Another good question was about steps for identifying on an older property what would be, kind of the steps that you would take to get a system in and to increase that efficiency. Maybe if you can just give us a couple bullet points on how you determine. And then another question kind of related to that was, how do you determine where to put the panels, whether it's on the ground or on the roof, that sort of thing?
So it's very case by case. If there is a shading issue, if the roof is old, the really nice thing about the 26% federal tax credit incentive is if you do have a really old roof and you do need to replace your roof, even in the next 5 or 10 years, you can go ahead and replace your roof and then add solar and then include your new roof in that whole solar project and get 26% off of the solar system and your new roof under the umbrella solar project cost, which is really, really nice. If there's a shading issue and you do have a bunch of, a decent amount of land, that is definitely when a ground mount would come into play and be much more helpful, but the ground mounts are more expensive. So it's like the roof mount really is the cheapest, best option, most cost-effective option. But sometimes it's not possible. Sometimes homeowners don't want the panels on the roof. Sometimes they would prefer them out. So it really, really is a case-by-case basis. Now, as far as energy efficiency with these older homes, LEAP has a really great energy efficiency program that they do a free home energy audit, and they will actually come out and help very specifically for your house tell you what energy efficiency upgrades can be made so that that loss of energy isn't happening as much. But yeah, other than that, it's like blown insulation, really finding any leaks in your house where that is, and that's what LEAP helped us with that with home energy audit.
And then what about ongoing maintenance? What do you have to do? How often? That sort of thing.
Absolutely nothing. Absolutely nothing. Sunday Solar, actually, we have a 10-year workmanship warranty that includes a very special quarterly monitoring, where we have a designated person that goes out to all of our installations on a quarterly basis to make sure that every single panel and every single inverter, everything is working and producing at the highest level that it should be, so that any problems, any faulty anything, we can find it and fix it before there's any loss of energy.
Great. Anything else? Anybody have anything else?
Josh, when Alicia said something about the value on the home by putting the solar panels on, how do you come up with that value? Who comes up with the value?
You know, that's a great question. I had that in my notes. It's just kind of like a general number that is associated that with what the increased value of the home is. If you Google how much solar is going to increase the value of your home, that's the number that's going to come up. There is quite a bit of data if you do Google that and showing where that number is coming from, but it is not a number that I made up or just pulled out. It's the number that what the average is across the board for what that value increase is.
We love Google.
Right. And if you read it on the internet, it must be true, right?
Yeah, there's been a number of studies that compared sales of similar homes with and without, and the average resale value change was 4%. So it's sort of it might be a secondhand number because you don't know the particulars, but it was a very large sample size where they tried to control for other differences like pools and acreage and that sort of thing.
And I think that's why on it's up to 4%, home increased value.
And just like with medications, your personal results might vary.
Exactly.
Awesome. Well, thank you so much, Alicia. We appreciate it, and Jimmy as well. And if you guys have more questions for them, obviously you can check out the handouts and feel free to give them a ring or shoot them a message. And really appreciate your time. You guys also, attendees today, will receive a brief survey on this session next week via email. So make sure you look out for that. And we hope you'd provide us feedback so we can continue to improve the series as well. So the next one will actually be on Friday, June 18th at 9 a.m. And this focus will be on understanding the building envelope. So please join us for that. Also, before we end today, I just want to remind everyone that the virtual Albemarle Housing Improvement Program 5K or 1 mile family fun run is happening now through May 29th. I think everyone kind of is familiar with AHIP, but it is definitely their mission to help our neighbors in need with critical home repairs. You can sign up as either an individual or gather some of your friends and do a team. And the best part is knowing that you're going to help AHIP and your neighbors in need. And $10 of the $30 registration fee is going to go directly to AHIP, and you'll have the ability to make an additional donation if you like to during the registration process. Thank you so much for joining us today. I hope you have a great weekend, and we will see you in June.
Bye, thank you.
All right. Thank you, guys.